Identifying conic sections, day 12. So today we are going to identify and transform conic sections. Remember, a conic section is when you take a slice of two cones that are placed on top of each other. There are four different types: circles, ellipses, hyperbolas, and parabolas. The equation of a conic section can be written in the form ax squared plus by squared plus dx plus ey plus f equals 0, where a and b are not both 0. The conic sections are listed at the left. The standard form of their equations are listed in the center, and we're going to talk about a few characteristics to tell the difference between them. When we talk about circles, we have to have two squared terms. So you are going to have an x squared and a y squared in order for it to be a circle. It has to be set equal to the radius squared, and your terms are always going to be x squared plus y squared. When we look at a parabola, how we tell it's a parabola is there is only one squared term. It is the only conic section that has one squared term. When we look at an ellipse, we also have two squared terms. It is also going to be adding x squared plus y squared, except your coefficients are different for both the x squared and the y squared. A circle, your coefficients are the same. For a hyperbola, we're also going to have two squared terms, except one of those terms is going to be negative. So that would be an example, x squared minus y squared. Remember, depending upon if it's vertical or horizontal, your x or your y could be negative. So this slide right here is very, very important to have memorized, and hopefully at this point you already do. How to identify conic equations. So we can ask ourselves these three questions to identify which conic equation we're talking about. The first question you ask yourself is, how many variables are squared? If you answer 1, it is a parabola, and you're finished. You have determined your conic section. If you answer 2, you need to rewrite the equation so both of the variables are on the same side and move on to your second question. The second question is, are both squared terms positive? If you answer no, you know your conic section is a hyperbola, and you are finished with your questions. If you answer yes, you need to proceed to question 3. Are the coefficients of the squared terms the same? If your answer is yes, you know your conic section is a circle and you're finished. If your answer is no, your conic section is an ellipse and you are also finished. So let's classify and write each equation in standard form. On this slide, we just want to classify what we're working with. So when we ask ourselves their questions, how many variables are squared? 2 variables are squared, so we need to move on to question 2. Are both squared terms positive? Our answer is no, so we know that this is a hyperbola. Number 2. 16x squared plus 9y squared. How many variables are squared? We have 2 squared variables. Are both of the terms positive? Both squared terms are positive. So then we need to look at our coefficients. Our coefficients of our squared terms are different, so we know we're talking about an ellipse. Number 3, we have 1 squared term. So we know we're talking about a parabola. Number 4, we have 2 squared terms. Are both squared terms positive? No, our second one is negative, so we know we're talking about a hyperbola. two squared terms. Their coefficients are the same, so we are talking about a circle. Two squared terms, our coefficients are the same because they're both positive, so we are talking about a circle. Example 7, we have two squared terms. Both squared terms are positive. Our coefficients are different, so we're talking about an ellipse. Question 8, we only have one squared term, so we are working with a parabola. The next slides, we are going to write each of these equations in standard form. So I'm going to do one example of a circle, a parabola, an ellipse, and a hyperbola. So to write example 1 in standard form, we need to make sure and group our numbers next to one another. Our x squared term, because this is a hyperbola, is negative, so our x's are going to come second. So we have y squared plus 4y plus our box. We have negative 2x squared plus 8x. I'm going to go ahead and move my 20 to the right. I need to factor out my negative 2 from my x's before I complete my squares. So I have x squared minus 4x plus box equals 20 plus 2 boxes. Our perfect square trinomial is above. Our two factors are below. B divided by 2 is a positive 2. 2 squared is 4. B divided by 2 is a negative 2. Negative 2 squared is 4. However, we factored out a negative 2, so on the right-hand side we have a negative 8. When we combined all of our like terms, we get equals 16. We know our hyperbola has to be equal to 1, so we divide everything by 16, and our standard form is y plus 2 squared over 16 minus x minus 2 squared over 8 equals 1. Number 3, where we had one squared term, so this was an example of a parabola. So we want to keep our linear term that does not have a squared term by itself on the left-hand side. So in this case, in order to keep my squared term positive, I'm going to subtract my 8y. So I get negative 8y is equal to x squared minus 8x. And I'm going to put my plus 32 over to my other side. I'm going to complete my square. So negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Put your plus 16 in your box on the right. 32 plus 16. Oh, excuse me, this should be a negative 32 because we moved it. So we're going to have a negative 16. When we move that back over, it becomes positive 16. Is where that came from. Equals our negative 8y. Divide by our negative 8. Remember to divide everything by negative 8. So we have y is equal to negative 1/8 x minus 4 squared minus 2. And we just wrote our parabola in standard form. Question number 5, we had two positive squared terms and their coefficients were the same, so we are working with a circle. Again, you want to group your x's and your y's together. Move your constant to the right-hand side of your equation. Add your boxes. b divided by 2 gives us negative 3 squared. 3 squared is 9 to both sides of our equation, plus 16 divided by 2 is positive 8. 8 squared is 64. 152 plus 9 plus 64 is 225. And we just wrote the standard form of our circle. We have two squared terms in number 7. Their coefficients are different, so we are working with an ellipse. Group your x's and your y's next to one another. Move your constant to the right-hand side. Factor out your greatest common factor. Add your boxes. Add your boxes to the right. 4 times the quantity of x, b divided by 2 is negative 4 squared. Negative 4 squared is 16. 16 times 4 is 64. b divided by 2 gives us a positive 3. 3 squared is 9. 9 times 3 is 27. 5 plus 64 plus 27 gives us 96. An ellipse needs to be set equal to 1. So we're going to divide everything by 96. So we get x minus 4 squared over 24 plus y plus 3 squared. 96 divided by 3 is 32 equals 1. And we just wrote standard form of our ellipse. So you now can classify conic sections based upon those questions and that chart to help us remember the different characteristics.